Good morning, dear students. Let me discuss Kirchhoff's loop rule and junction rule for this particular circuit to understand what are Kirchhoff's laws. It is called junction rule. Now, this whole circuit I have drawn well in advance. You have a cell of 45 volt and where you have 1 ohm and 40 ohm connected in series, and this is 30 ohm, and you have 80 volt once again, a cell of EMF and 1 ohm resistor 20. This is called a circuit. To simplify such circuits into series and parallel, it's very difficult. Hence, Kirchhoff suggested two statements. One is called current law, the other is called voltage law. Current law is called junction law or a junction rule, or voltage law is called loop rule or Kirchhoff's loop equation. So to apply both the laws, current law and voltage law, I need some circuit, a simple typical circuit, which is made up of cells, cell 1 and cell 2, and some different values of resistor. Let me understand what is a junction. As I said, junction is a point in a circuit where 3 and more than 3 conducting paths come and meet. So according to the, I just highlighted, let this point be A, taken as A. A is a junction according to statement. So this conducting path comes and meets here. This conducting path also comes and meets here. This conducting path come and meet here. Now, if I take some current is coming out from this particular, if current is flowing in this part, and if I say current, let current, according to textbook, it is I3 be the current which is entering a junction. Now, when I3 is entering, and since it is a negative, I can say let it be I2 here. I2 is current. With respect to this junction, I3 is entering, I2 is leaving. Let you take it as I1, which is moving out. I1 is a current which is going out. If I take A as a junction, here amount of current entry is I3, current leaving is I1, and current leaving is I2. I can apply A is a junction. A being a junction, I can write a junction rule. The current entry, amount of current entry equal to amount of current leaving. Amount of current entry is I3 is equivalent to I1 plus I2. So you can notice once again, A is a junction where current entry is only I3. There are 3 conducting paths, 1, 2, 3. Current enters through this path, current leaves from A, and current also leaves from A. Hence, I1 and I2 are going out. I1 and I2 are the current going out, and I3 is the current entering, and A is a junction. Now, similarly, H is not a junction. H is a point here, not a junction. D is a junction. Now, look at this. This I1 current flows through 30 ohm and it enters here. Again, the amount of current enters here is I1 because it enters. Now, this current I2 moves here in this path. This is I2. I can write because it enters from an N terminal. It goes to the P terminal. It is called N electrode, negative electrode, positive electrode. I2 is a current. Again, I2 enters here. You can take I2 is the current which is entering here. And now this current which is I3 here, if this is I3, everywhere is I3 here, you can write it here I3. You can take this is I3. I repeat, this is a positive electrode. If this is I3, this here also I3 current, here also I3 current, here also I3 current. I3 enters here from N electrode to P electrode. So what is the current entry? I1 enters at D, I2 also enters at D, I3 leaves it. Hence, at junction D, again the formula, current entry equal to current going out, current entry equal to I1 plus I2, which is equivalent to I3. Hence, I can say the net current entering at A junction and D junction is equal to 0. This is the algebraic sum of current entering a junction at A point and current entering at D point is going to be 0. Hence, for A junction, this is a relation. For D junction, this is a relationship I discussed. As first part junction rule we studied at A junction and D junction, let me go for loop rule. The loop rule says that the algebraic sum of EMFs and potential difference across the resistors is equal to 0. This is mathematically written as V equivalent to 0. Let me understand what is the sum of EMFs plus potential differences across the resistor is equal to 0. What is the statement? Loop rule says that, Kirchhoff's loop rule says that, or voltage law says that the algebraic sum of the EMFs plus potential differences across the resistors in a closed loop is a 0. I repeat, the algebraic sum of EMFs plus potential differences across the resistors equal to 0. What is a loop? If I start from a point A, if I go through a circuit, like I move from A to H, then to D, then this is a point C, then B, then A. This is called one loop. A, H, D, C, B, A. The starting point and the end point are same. I started at A, I move to H, then D, then C, then B. It is called you traverse a loop. That's why to convey you much better, A means here. You start from A, you traverse through the loop. This arrow mark indicates this is called traveling path. It is called travel direction. The travel direction of the path. You start from A, go to H, then go to D. D means here. Then C point, then B point, then back to the pavilion. This is called A point. Starting point and end point should coincide. That is called a loop. What is a loop? Loop is an imaginary path in the circuit. This is an electronic circuit. Loop is an imaginary path in the circuit. You assign it as A point, H point, D point, C point, B point, A point. Then you travel. When you travel, this is called travel direction. And what are the direction of current? This is, yes, I failed to write. This is I1. I1 already written here. Yes, sorry. I1 is a current. Now look at this arrow mark and look at this path. This path is called A, H, D, C, B, A. This loop. I'm talking about this loop. This loop is, you start from A, you go to H, you go to D, you go to, sorry, A, H, D, C, B, A. This loop I'm starting. Now, look at this A to H. Only one resistor is present, 30 ohm. When you traverse from A to H, first A to H, the direction of current and direction of loop are one and the same. If both are same direction, the product is called potential difference. Resistance into current. Current is I1, resistance is 30. The product, that is called potential difference, 30 I1. If the direction of the current and the direction of the traverse are in the same direction, the EMF across the resistor should be negative. It is taken minus 31. Now I completed AH. Then H to D. H to D, there is no resistor or no cell. Now D point to C point, there is a cell. If the direction of traverse, this is direction of traverse, if it enters from N and if it reaches a P, if it is entering from negative terminal to positive terminal in this path, so I can take the EMF across the cell as positive, that is plus 45. Next, I reached C point. We completed D to C. Because from D to C, there is a cell and the direction of a travel, it is called direction of travel. It enters from N, it enters to P. It is entering from N, lower potential. I can say negative potential. Hence, I can take plus 45. Next, we have two resistors which are in series. Whenever resistors are in series, I can take it, they can be added 40 plus 1, 41. And if current is I3 here, here also I3, the same current is flowing here. I can take I3 is a current. Hence, the potential difference across these two resistors is taken as 41 into I3. Since the direction of travel and the direction of current are same, this direction is also in this case, same direction, I can take minus 41 I3 equal to 0. So what I mean to say, if the direction of travel and the direction of current are same, the product should be taken negative. Cell positive. Why? It enters from the negative electrode. Yes. And these two resistors are taken together. 40 plus 1 becomes 41 ohm and the current is I3. The product is 41 I3. And looking into the direction of a current and the travel direction, both are same. Hence, I'll be taking minus 41 I3. This is called an equation written for electrical circuit for loop, first loop. Yes, this is first loop related explanation. Now, similarly, let me write an equation for another loop. Another loop is again this loop. It starts from A, goes to H, again D, then it moves to E, E to, again you have a F here, then back to A. The next loop is second loop, another loop, A, H, A to H. You start from A, go to H, go to D, D to E, E to F, F to G, G to A. A, H, D, E, F, G, A. Again, the starting point and the end points are one, hence it is called a loop. If I, this is the arrow mark. I have already drawn the arrow mark. This is the path. What is the path? If you start from A, this is called a travel direction. You are traveling. Yes, in this path. This arrow mark is called travel direction. Travel direction. When you move from A to H, again same thing, same current is flowing. The direction of travel and the direction of current are, this is called direction of current, this is I1, and this is travel direction. Both are same. Hence the product minus 30 I1. I repeat, the current is I1 in this path, A to H, and the path direction, travel direction is also same. Hence the product is called potential difference. Potential difference means 30 into I1. 30 means resistance, I1 means current. Next, when I reach D, up to here, reach D over, I travel from A to H, H to D over. Now, when I move from D to E, there is a resistor of 20 ohm. The direction of current and the direction of travel are opposite. You can notice this is called travel direction. It is downward, this is upward. I repeat, the direction of travel is downward, the direction of current is upward. Since they are in opposite, I can take the product positive. 20 I2 means plus 20 I2. Now, I move from D to E over, D to E over. I move from E to F. Again, there is a resistor of 1 ohm. The direction of travel, look at this arrow mark. It is from right to left. It is from left to right. Both are opposite. Hence, again, the product means plus 1 I2. Product means 1 ohm into current. Current is I2. 1 into I2. That is a plus. Finally, now the direction of travel, it enters from P to N. Since the direction of travel, this is called direction of travel. Since the direction of travel is entering at positive electrode and leaving negative electrode, I can take it as a minus 80 equivalent to 0. So I hope it's very clear. Minus 30 I1 plus 20 I2 plus I2 minus 80. I can rewrite it. These two can be added. Minus 30 I1 plus 21 I2 minus 80 equal to 0. This is a next equation. Yes, I have two unknowns, I1, I2. I have I1 and I3 unknowns. Using these two equations, I can calculate I1, I can calculate I2, I can calculate I3 values. So this is how loop rule and junction rule is applied to understand what is current value in the circuit.